Hi, my name is Gennady Tsar. I'm with Absolute Mechanical, and I'm gonna give a brief description and the purpose of each component of this installation. This is the steam system. We try to follow the principles of the green steam. It's a high efficiency steam. So what we have here is the main component is the boiler. It's a steam gas-fired slant fin boiler, excellent boiler. We have a control trim. We have a pressure control. It's a vapor start. It works on the pressure below 1 psi and ounces of the steam. So this is the operating pressure control. This is the manual reset pressure control. If this control is not working, then this control trips, and you have to press this red button to restore it. But it's just to let you know that something wrong with this control. So this is the operating device. This is the safety device. Now, if this device is gonna go out of order, it's gonna break, or it's gonna clog, or any other issues, then we have a pressure relief valve. This is 15 psi pressure relief valve. So if the pressure exceeds 15 psi, it's gonna open and relieve the excess steam, preventing the system to be dangerously overpressurized. The water level of the boiler is controlled by the low water cutoff. So if the water level will drop below set point, it will turn off the boiler. If this device, it's automatic reset, low water cutoff will go offline, or it's not going to work, or it's going to get dirty. By the way, it's a good thing to flush it once in a while to remove the dirt and the stuff accumulating under the float. So if this low water cutoff will go out of order, then we have a secondary device. It's a manual reset low water cutoff. So it has two lights. It has a green light and it has a red light. If the red light is on, it means it's tripped. So then what you do, you just reset it. The button says reset. You press reset, and if there is water in the boiler, it's gonna go on. But you can test its operation too. The second button is a test button. By pressing it, you imitate the low water condition, and then this device has to stop the boiler, and to restore boiler to operation, you have to press the reset button. Now, to test this device, maybe once a month, once in 2 months, it would be a good idea to check if it works. Now, this piece of pipe is the cap. We left it especially for the purpose of adding the chemicals into the system. So during the annual maintenance, if chemicals needs to be added to the system, you just shut the boiler down, make sure that there is no steam in there. What you do, you just open up this valve, no steam, you're closing it, and opening up the cap and pouring the chemicals inside. This is the water level side glass. Actually, this boiler has automatic feeder, so the arrows here showing the water line supported by the low water cutoff. Also, looking at the boiler, there is a water level sign over there, which shows the normal low water condition for the boiler. Now, this is automatic feeder. It gets its signal from the low water cutoff. If the water level goes down, this low water cutoff sends a signal to the feeder. Feeder opens up and feeds the boiler. It has a built-in counter, how many gallons of the water was fed. This is the chart of the normal, water loss in the system. And also this low water cutoff has also a bypass. This valve over here is a bypass. You can open it and feed the water manually to the boiler in case if this device will go out of order. This is the backflow preventer. Backflow preventer is, in essence, is the check valve, but it's more complicated check valve. So it prevents cross-contamination. It prevents the dirty boiler water backflow into the potable water supply in the building. Now, what we have over here, this building has two types of system combined in one. It's the main building has a steam system, and the addition to the building has a hydronic, it's a hot water heating system. Now, hydronic heating system is served by this pump. It's a variable frequency pump. It's a Taker Bumblebee. This pump operates on the speed of the pump depends on the temperature of the return and supply. So if the temperature difference is within the settings, then the pump pumps a certain amount of gallons through the radiators. If the space gets colder and the radiators get more heat from the water, the return temperature drops down, and the temperature of the return water drops down, then this pump speeds up and sends more water to the radiators. So now here, this is the three-way valve. Three-way valve, it has a sensor outside. So this three-way valve is the automatic actuator. It senses the temperature outside, and then it sets the temperature going to the space depending on the temperature outside. So the colder is outside, the hotter the water is pumped into the space radiators. If the weather gets mild outside, then the water temperature goes down, because you don't need the radiators so hot when it's warm outside. So this way it controls a output from the radiators in the space. Now this is the switching controls, which actually what they do, they interlock the high voltage 120 volt pump with the low voltage control. So this is actually a link between the control wiring, low voltage control wiring, and the power wiring of the pump. Now this is the air eliminator, because we have sometimes the air gets into the hot water system. So what this device does, it removes air from the water constantly, so you don't have to bleed the radiators. This air separator takes care of all the air in the system. Expansion tank right here. This expansion tank takes care of the thermal expansion of the water, because if the water is heated, it expands. So if we have water expanding in the enclosed space in the piping system, then we have the pressure starts to go up dramatically, and the system either can burst or it triggers the relief valve. The hot water system also has a pressure relief valve, which prevents the water getting into the excessive high pressure. But we don't want this valve to trip, so we have an expansion tank which takes care of the expansion of the water. Now this system, hot water system, needs to be fed initially, or if there is any water loss. So what we have here, we have a feeder. It's a Calefi feeder with a very interesting feature. It allows to preset the pressure, calculate it, and that's probably about it. It's gonna keep the pressure which you set initially. This is the difference between the earlier versions of the valves of other manufacturers. Whether you just have to go by the heating, or is it feeding or it's not feeding, but this one you just set and forget. This is, again, it's a cross-contamination prevention device. It's a backflow preventer. Now what we have here also, we have a Johnson Control A419, which is used as a warm weather shutdown, which means that if the temperature outside gets above preset temperature, then the heating portion of the system will no longer provide heat to the building, because you don't need heat when it's 60 degrees outside.
Does that apply to the hydronic and the steam?
Yes, it just turns off everything heating. Now this is another interesting device. This is the Honeywell thermostat with the remote sensor. So the sensor itself is located on the first floor, and it's wireless. So when you install this device, you don't need to hire an electrician and spend you know, $1,000 or in excess of $1,000 just to run the wires to the whole building. You just hang the wireless sensor on the wall, and you get the reading of the humidity, you get reading of the temperature, set points, everything. And because the thermostat is in the basement and the sensor with no buttons in the apartment, it completely strips the tenants of the capability to alter the settings. And if some smart tenants want to do it and they want to place a bag of ice on the top of the sensor, good luck, you're not going to have heat for 2 hours because it feels the attempts to temper. So if you don't want to have heat for a couple hours, try to play with the sensor. Okay, now what we have over here, also another device, which is right here. It's a indirect water heater. It's a storage tank with the potable water, hot water, and it has a coil inside. So this coil is fed from the same boiler with this pump. The hot water is circulating through the coil and hits the potable water. It hits pretty hot, above, you know, above legal limit of the hot water going into the building, because there is a plumbing code regulations which prevent supplying the very hot water to the faucet. So here we have a temper valve, a mixing valve. So what the mixing valve does, it takes a hot water from the boiler and it takes a cold water from the cold line, and it mixes to the preset temperature. And this is the mixed water, completely within the legal range, going to the faucets. Now, what we have over here, we have also a domestic hot water return line with the pump and control. What this pump does, because if in the situations where nobody using hot water for quite a while, the water gets cold in the hot water line. So what you have to do, you have to open the tap and run the cold water until the hot water comes in. So it leads to the necessary waste of the potable water. So this pump has a sensor, aquastat, which feels when the line gets cold. It turns on the pump pumps the hot water, you know, it circulates the water from the hot water lines through the tank and keeps it hot all the time. So whatever you open the hot water, you get hot water right away. Again, this tank has also its own relief valve, which if you overheat the water in the tank, of course it's gonna expand. And for this purpose, we have a second expansion tank right here. This expansion tank is an expansion tank for the potable water. So it takes care of the thermal expansion of the potable water in the tank and in the system. Another very necessary and often overlooked feature. That's probably all about the components of the system.
Okay, thank you.
You're welcome.